Alright, so we are now on section 4.6, which is finding asymptotes and limits at infinity. And our first problem is problem number 271, and the function is x minus 9 over x. Technically this is a rational function, but I've got the function over here on the graphing calculator, and x minus 9 over x. And if we graph this, this is the rational function x minus 9 over x. It appears to have a couple zeros, maybe one at 3 and another one at minus 3. It looks like it's got a vertical asymptote at x equals 0, and maybe an oblique or slant asymptote, maybe y equals x, something like this. Okay, so this is from intuition. Let's go ahead and look at the function itself. So we've got f of x equals x minus 9 over x, and if I look at the domain of this function, so the domain of f is minus infinity to 0 union 0 to infinity. Notice I can't divide by 0, and the 9 over x is undefined at x equals 0. So we will have a vertical asymptote. In fact, if I look at the limit as x approaches 0 from the right of f of x, this is going to be the limit as x approaches 0 from the right of x minus 9 over x. And the first part of it, as x approaches 0 from the right, of x itself just goes to 0, so this will just be 0 minus the limit as x approaches 0 from the right of 9 over x. And here the negative sign came through the limit, and as x approaches 0 from the right, this is something small and positive, and so this is going to blow up to positive infinity, but there's a negative there, so let's go to minus infinity. And if you look at the graph over here, as x approaches 0 from the right side, it looks like this thing goes down to minus infinity. Similarly, if we look at the limit as x approaches 0 from the left, this will be the limit as x approaches 0 from the left of x minus 9 over x. And so as x approaches 0, this first term is going to just go to 0, minus the limit as x approaches 0 from the left of 9 over x. 0 is going to be slightly negative, and so this is going to go to minus infinity, but then there's a negative sign out here, so this will be positive infinity. And so the limit as x approaches 0 from the left of f of x, oops, I should probably have f of x up here as well, will be positive infinity. And again, looking at the graph, as x approaches 0 from the left hand side, this is going to infinity. So we're going to have a vertical asymptote at x equal 0. Okay. Now, I did say that there appeared to be an oblique asymptote, and so for the first part of this, we looked at x approaching 0 from the right and from the left, and we saw it went to minus infinity or positive infinity. And now I'm going to look at the end behavior, meaning the limit as x approaches, say, positive infinity. And if we look at the second term here, as x gets arbitrarily large, I'm taking 9 and dividing by a large number. This is going to go to 0 here. And so this is going to limit as x approaches positive infinity will be, limit as x goes to infinity, and this will be a minus 0. So it's going to go to infinity. But the graph will look like y equals x as you tend toward positive infinity. And again, over here, on the graph, this right-hand side, as x becomes more and more positive, it's tending toward a straight line y equals x. And that's what we see over here. As x approaches infinity, it's looking like the function y equals x. So the limit does go to infinity, but from a function point of view, it's looking like the line y equals x. Now if we go the limit as x approaches minus infinity, we'll have the same thing. And this term here is going to go to 0 because x gets arbitrarily large. This is going to look like 9 divided by something large, which will go to 0. So this will be the limit as x goes to minus infinity of just x, which of course will go to minus infinity. But this is going to look like, from a function point of view, y equals x. Again, looking at the graph over here, as x tends toward the left or goes towards minus infinity, it's looking like a straight line y equals x here. And so here the limit at infinity will go to negative infinity. Here the limit at positive infinity will go to infinity. So I guess I should be technical here, and this will go to infinity. And on this side, this will go to minus infinity. But it will look like y equals x as far as an oblique asymptote. Alright, so our oblique asymptote is going to be y equal x. And our horizontal asymptote we don't have, but our vertical asymptote is going to be x equal 0. So as x approaches 0 from the left to the right, it went to positive or negative infinity. And when we looked at the far ends, meaning the end behavior, as x approached positive infinity or x approaches negative infinity, the function itself approaches the line y equals x on either side, positive infinity or negative infinity. It's still going to infinity or minus infinity, but it's approaching a straight line. And that concludes this problem.